Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wala. In the last session of Simple Harmonic Motion, where we discussed the basic terms related to the S.H.M, and after that we have discussed what is the equation of the S.H.M, and we did some questions related to that, right? Chal. So today the lecture number 3, the important topics we are going to discuss. So one is a project S.H.M as a projection of uniform circular motion. The other one is energy in the S.H.M, like kinetic energy and potential energy, and what is the total mechanical energy of the S.H.M. Okay, so here in S.H.M as a projection of UCM, so some questions were asked in previous year, NEET as well as JEE. So we'll understand this topic in detail and then we'll go for the energy in S.H.M. So as usual, I just need your attention for the next 1 hour, guys. Just be with me, avoid all the disturbances around you for the next 1 hour. So, and at the end of the lecture, it's very important to prepare your own short notes. And the students, those who are in class 12th and droppers, you guys should gear up your preparation. So attempt a more mock test, so more previous year questions, complete the backlogs, so make your own short notes and revise it daily. So that should be a routine for you guys. Clear? Chal. So let's get into the today's topic with a question. So this question I gave it as a homework in the last session. Remaining questions you can solve it easily. So this question I'll explain. So try to do along with me. Two particles are oscillating along two close parallel straight lines side by side with the same frequency and amplitudes. So they pass each other moving in opposite directions. So when their displacement is half of the amplitude. Yes. So try to understand this concept. So there are two particles are oscillating along the two close parallel straight lines. So one particle is moving this side in this path. So the another particle is moving. So parallel straight lines. See here, parallel straight lines side by side. So like this. Then, so with the same frequency and same amplitude both. First understand the question in detail. So they pass each other moving in opposite directions when their displacement is half of the amplitude. So the particle 1, let's suppose its displacement it reached here. Let's say, so the particle 1 it reached here. So this is a place where the displacement is half of the amplitude, and the particle 2 is also reached half of its amplitude, x is equals to a by 2. So at this point, so they are in opposite directions at this point, where when their displacement is half of the amplitude, so they are opposite to each other, which means, so let's say this particle is moving this side and the second particle will be moving towards right. This is what the opposite direction, right? Chal. So the mean positions of the two particles lie on a straight line perpendicular to the paths of the two. So the mean position so lies somewhere around here, perpendicular to the paths. Okay, so let it be the mean position of this one and let it be the mean position of this one. One particle is coming from there and another particle is going from here. So at exactly the mid, at x is equals to a by 2 place, they are facing opposite to each other. The concept is clear. Now, so what we have to find? So the mean, so the phase difference we have to calculate. So what is the phase difference, right? Yeah, chal. So first of all, let me take any general equation. So the x is equals to a sine. So let's say they have some initial phase phi, because we have to find that phase difference only, right? So the initial phase, let it be phi. So x is equals to a sine omega t is the general equation of the S.H.M, and if they are in initial phase, some initial phase is there, so phi I am including. So now the displacement x is a by 2 for both the particles. When the displacement is a by 2, so there you have to find what is the phase difference between them. Shall understanding at this place what is the phase difference between them. So when the displacement is half of the amplitude, what is the phase difference between them? So a into sine omega t plus phi. Chalo. So here a gets cancelled. So we get 1 by 2 is equals to sine of omega t plus phi. So now understand this carefully. So we got So the sine of omega t plus phi is equals to 1 by 2. Done. Sure. So now shall I write this as, so omega t plus phi is equals to 1 by 2, like this 1 by 2 will come in how many places, like for which value of sine we get the 1 by 2. So 1 is 30 degrees. So the sine 30 is 1 by 2. Yes. So now for any other angle, it will be 1 by 2 again. So shall I say that the sine of 150 is also 1 by 2? How, sir? So in the basic maths you learned, so the sine of, so 150, what is 150 means? I can write it as 180 minus 30. So sine of 180 minus theta. 180 minus theta lies in which quadrant? Second quadrant. Second quadrant sine is positive. Right, second quadrant sine is positive. So then I can write sine 30, it will be plus sine 30. So what is sine 30 value? Again 1 by 2. Understood the simple logic? So that means, so one has a phase, I can say, so the phase of the first one, here it can be 30 degrees or 150 degrees. They are asking what is the phase difference between them. We have to find this whole phase difference. Right. Chalo. So now let's say this particle is making 150 degrees. So this particle is making 30 degrees. So now the phase difference, the delta phi, so the phase difference delta phi will be equals to between those two. So 150 degrees minus 30 degrees, obviously it can't be negative. So that's why more minus less, 150 minus 30. So which will be 120 degrees. So convert it to radians. So in terms of radians, so I can write, so 2 pi by 3. Yes or no? So in terms of radians, it will be 2 pi by 3. So the simple question, so the correct option is option 3. Understood, guys? The concept is clear. So there are two particles, so which are moving in opposite directions when their displacement is a by 2. So then we calculated, so this phase, so the first one's phase is 150, the second one's phase is 30. So then the phase difference will be 150 minus 30. So 120, that is 2 pi by 3. Done. Chal. So now let's move to the next concept, that is S.H.M as projection of uniform circular motion. See, so the uniform circular motion is not a S.H.M. First of all, here UCM, the uniform circular motion, it's not S.H.M. Right, it's just a periodic motion. In the first class of simple harmonic motion, we discussed in detail. Right, so uniform circular motion is a periodic motion, but it's not a harmonic motion and it's not a simple harmonic motion. That's clear now. But the projection of, but the projection of uniform circular motion, let me tell you. So let's say at time t is equals to 0, so a particle is making, a particle p is making the uniform circular motion. So a particle p, let's say a particle p, so it's undergoing S.H.M, not S.H.M, uniform circular motion, let's say. So it's undergoing uniform circular motion, which means, so this particle p is moving from here to here, and then here to here, so then here, so then here, so to this place, and to this place, so to this place. So it's covering equal distances in equal interval of time in the circular path. That's called the uniform circular motion, right? Chal. So now the projections of this particle on any diameter will give the S.H.M. So let me explain you carefully. So when the particle is this here, so let's say when the particle is here, so let's draw the projection of it on the x-axis, on the diameter, horizontal diameter I am taking. So when the particle is here, let's say, so the projection of it on the x-axis will be here. When the particle reached here, so the projection will be here itself. So when the particle is here, so the projection will be here. When the particle is here, so the projection will be here. So when the particle is here, the projection will be here. When the particle is here, the projection is here. Or you take one more point here. So here, the projection will be here. So when the particle is here, so the projection will be on the horizontal diameter here, right? So similarly, when the particle is here on the horizontal diameter, so the projection will be somewhere around here. So then here, so then here, so then when the particle is here, so the projection here, so here, and then here, so then here. So that means you observe that. So when the particle is moving in the uniform circular motion, so its projections you can see. First the projection is here, so then the projection is here, so then the projection is here, and the projection is here. And again in this cycle, so the projection when it is here, the projection is here, again here, again here, 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 so then next here, next, 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 so here. And when the particle is moving from here to here, when it is moving from here to here, it's the S.H.M is from here to here, and then this one, so this one, this one, this one. That means when the particle is making the uniform circular motion, so the projections on the diameter is making the S.H.M first to the right extreme, then from there to the mean, from to the left extreme, again to the mean. So that means, so the particle undergoing uniform circular motion, so the projection of it on any diameter, I can consider any diameter. So if you want to take vertical diameter, you can take the vertical diameter also. See, its projection when here, so when projection is here, so when projection is here, so then when it is here, so it will be here, so then the projection is here, so the projection, so here, so then again here. See here, so the particle is first moving to the mean, then extreme, then mean, then extreme. So that means, so write down the statement. A particle undergoing S.H.M, the projection of particle on any diameter, so makes S.H.M. So the projections make the S.H.M, not the uniform circular motion. Uniform circular motion is not an S.H.M, but the projection of uniform circular motion. A particle is undergoing uniform circular motion, so then its projections on any diameter will perform the S.H.M. So clear this point? Understood everyone? So either it's a horizontal diameter or the vertical diameter, so it doesn't matter. In both the cases it performs a S.H.M. Right? Done? Chalo. So let's go for the projection on horizontal diameter. We will consider different scenarios. So try to understand this part. So let's say at time t is equals to 0, so the particle is at this place. At time t is equals 0, let's say this is a x is equals to 0 position. So now I am going to take the projection on the horizontal diameter. Horizontal diameter means this one, right? Chalo. So in time t, so the particle has reached here. So in some time t, so the particle has reached here. So let's say this is a maximum displacement A. Okay, chalo. So now, so this will be the theta. Let's say this angle is theta. So the particle is moving with a particle undergoing S.H.M will have the angular velocity, right? So let's say it's moving with an angular velocity omega. So in time t, it has reached this place. So then this will be the angular displacement. You know that the angular velocity is equals to, so the angular displacement upon time taken from here. So the angular displacement theta is equals to omega t. The angular displacement theta is equals to omega t. So this will be theta. So then this will be 90 minus theta, because this whole angle is 90 degrees. So if it is A, so shall I say that the projection, its projection on the x-axis, let it be some x, because we are doing the projection on the horizontal diameter. So this projection, this distance is a x, let's say the particle has reached here, so then its projection on the horizontal diameter, the distance x. So if it is theta, so this side a cos theta, this side a sin theta will come, because theta is this side, this will be a cos theta, this will be a sin theta obviously. So I can write, so the x is equals to A sin theta, right? And here the theta is equals to what? So here the theta is equals to omega t, right? So then the displacement of the particle will be A sin, so in place of theta I can write omega t. So x is equals to A sin omega t. So have you seen this equation anywhere? Have you seen this equation anywhere? So this is nothing but, so the particle which is performing S.H.M from the mean position to the right extreme. So consider this is a S.H.M on the straight line, x is equals to 0, t is equals to 0, at time t is equals to 0, x is equals to 0. So the particle is moving towards the right extreme. So for this the equation is x is equals to A sin omega t, which is the most popular general equation of the S.H.M. So the same thing we got for this. So that means if this particle starts from here, so and it's undergoing the uniform circular motion, so then its projections on the x-axis will be making the S.H.M x is equals to A sin omega t. Clear? Sure. So now let's take the another scenario where, so consider, let's say the particle is starting at time t is equals to 0. So let's say this is the initial position. At time t is equals to 0, this is the initial position. So now the particle is moving with the angular velocity of, let it be omega. Now after some time t, at time t is equals to t, so the particle has reached this place. So here the particle started from p point, so and it reached some p dash point. Clear? Chal. So then it's let it be, what is the angular displacement? Let this angular displacement be theta. Let this angular displacement be theta. Now so its projection on the x-axis, so here this will be the projection on the x-axis, as the theta is this side, so I can write, so as theta is this side I can write this total is A, we consider. So then A cos theta, this will be A cos theta, as it is towards the right of the mean, consider it as plus A cos theta. Okay, so the x is equals to A cos theta. Now here we know that the theta is equals to what? So the particle is undergoing S.H.M with a uniform velocity, angular velocity omega. So what's that angular velocity? So theta by t. So from here the theta is equals to omega into t. So therefore here I can write x is equals to A cos in place of theta, so which is nothing but omega t. Have you observed this equation previously? So in a straight line motion S.H.M, so if the particle is at x is equals to 0, at time t is equals to 0, if it starts oscillating from here, x is equals to t is equals to 0, x is equals to 0, so then the equation for the S.H.M will be A cos omega t. Yes or no? So that means in the uniform circular motion, if the particle makes or starts moving from here, so then it will be equals to, in the straight line motion, so the S.H.M this way. Understanding? Clear? Sure. So next let me take, so let's say the particle is starting from this point. Let's say the particle is starting from this point here. So the particle p is starting at time t is equals to 0. Let's say this is the initial position of the particle. So we are taking only the projection on the x-axis, guys. Okay. So after some time t, let's say the particle has reached here at some time t is equals to t. So the particle has reached here. So then from here to here it covered angular displacement theta. So it's moving with the angular velocity, let it be omega. So now I am writing, so the omega is equals to theta by t. So from here theta is equals to omega t. So this is also fine. Now so I can write here, so what's the projection on the x? So if it is theta, so this will be x is equals to A sin theta, this point. If it is theta, so this side will get A sin theta. So now as it is to the left of the origin, as it is to the left of the center, so I am taking it as minus. So therefore x is equals to minus A sin theta. X is equals to minus A sin theta. Understanding? Chal. So then x is equals to minus a sine, what is theta? Theta is nothing but omega t. Theta is nothing but omega t. So this is a S.H.M equation when the particle starts from mean position towards a left extreme position, right? So towards a left extreme position in the straight line oscillation or the straight line simple harmonic motion. This equals to, so the particle which is starting from here in uniform circular motion, the projections of it will give the S.H.M which is equals to this one, sorry. Clear? Understood? Sure. So then consider one more scenario. Let's say at time t is equals 0. Hope you guys are understanding now. So this point is x is equals to 0 at time t is equals to 0. So then after some time t, so the particle has reached to this place. So then the particle reached, so this is a angular displacement covered theta. So let's say the particle is moving with some angular velocity omega. So we know that this omega is equals to theta by t. So then the theta is equals to omega t. The theta is equals to omega t. So now the projection on it on the x-axis on the horizontal diameter. So this is x is equals to, so theta is this side, it will be a cos theta. And as it is towards the left, so I am taking it as minus a cos theta. So which is nothing but, so minus a cos, in place of theta I can write omega t. So x is equals to minus a cos omega t. So what is this point? So this is a S.H.M. So the particle performing S.H.M from the right extreme position at x is equals to minus a, sorry. So at t is equals to 0. So towards the mean position. So this S.H.M, this is the equation of S.H.M equivalent to straight line S.H.M. Done. So in the circular motion, the particle is starting from here. In the straight line motion for the same equation, the particle will start from left extreme. We discussed it already. Alright? Chalo. So this one is also done. So projection on the vertical diameter. Before that, let's take one more scenario. So let's take. So consider. So only horizontal diameter is enough. Or let's take vertical also. So see here, let's say at time t is equals to 0. So the particle is starting from this place. So the mean position, the position from here. So let's say the particle is moving towards this side with a uniform velocity, angular velocity omega. Chal. So then at some time t is equals to t. So the particle has reached to this point. Okay, so then this will be a, the maximum displacement, let's consider. So then, so how much is the theta? This one. So now the projection on the x-axis. So this will be the projection on the x-axis. So which is equals to, the x is equals to, I can write a sine theta. As it is towards the left, so I can write it as, so the x is equals to minus a sine theta. As the particle is moving with the angular velocity omega, so that omega is equals to theta by t. Done. So from here the theta is equals to, we can write omega into t. Done. Chalo. So now you can substitute it here. So x is equals to minus a sine theta. Theta is nothing but omega t. So this is the equation. So in the straight line S.H.M, where, so particle starting from the at time t is equals to 0. So the particle starting from the mean position and moving towards the left extreme position. Whatever the equation of S.H.M that you are getting here, so the same equation you are getting for the projections of the particle undergoing S.H.M from this position towards this way, anti-clockwise. Understanding? So that means the particle is starting at different places. So we are getting the different equations of S.H.M. You can compare it with the straight line oscillations. Then when the particle is starting from here and moving in a clockwise direction, so then we can compare it with the particle which is making S.H.M from the mean position to the right extreme position. Or if the particle is making uniform circular motion from this point initially and moving anti-clockwise direction, clockwise direction like this, right? So then we can compare it with the particle which is starting its S.H.M from the right extreme position. This is not x equals to a, this is not x equals 0, this is x equal to plus a, x equals to plus a position. So this equation is x is equals to a cos omega t. And if the particle is starting its uniform circular motion from this point, so and we got the S.H.M equation, the projections of this on the horizontal diameter, we got the equation like this. So we can compare it with, so the particle which is moving from, so a minus a sin omega t, yeah, moving from mean position towards the left extreme position, right? Chalo. So then theta, so minus a sin omega t, right? Correct only, right? So this one is omega, so this is theta. So then so if it is theta, this will be a minus a sin theta, so minus a sin omega t, fine, yeah. So then here, so if the particle is starting from here, so we got x is equals to minus a cos omega t. So x is equals to a sin omega t, a cos omega t, minus a sin omega t, and then minus a cos omega t. Or if the particle starts from this position, you can take in reverse direction also, just for your understanding I discussed. So the particle starts from might be from here, so towards this place, or it can start from at t is equals to 0 in the anti-clockwise direction. So after some time it might reach here, and the horizontal projection you can take. So again you will get some other equation of the S.H.M. Understanding clear, everyone? Sure. So now the same thing you can do it for the vertical diameter also. So let's say the particle at time t is equals 0, it's starting from here. Let's say this is the initial position, x equals to 0. Done. Sure. So now let's say after it's moving with the angular velocity omega, after some time t, so the particle has reached here. So now we need the, let's say this is a. Now we need the vertical projection, because on the vertical diameter we need the projection. So what we can do, simply this is a projection on the y. So let's say this displacement will be obviously y. So for above the center, take it as positive displacement, below the center take it as negative, because this is a straight line. Simply you can imagine it with the straight line S.H.M or straight line oscillation. Done. So here, so I can write, so this is a theta. So if it is theta, so the y will be equals to a cos theta, obviously the y is equals to a cos theta, right? So what is theta again? So the particle is moving with a angular velocity of omega, so the omega is equals to theta by t. So from here the theta is equals to omega t, the theta is equals to omega t. So y is equals to a cos, in place of theta what we can write, omega t. So again this is a equation of S.H.M which is starting from the right extreme towards the mean position, right? So done. So do we have another slide? You can solve it in n number of ways, or if the particle starts from here, let's say at time t is, so do we have enough slides? No. So what I'll do is, so let's say I'll take the case 2 here. So let's say this is a case 1. So this is for the first scenario. So now I am taking the case 2 in the same slide. So let's say if the particle is starting from at t is equals to 0, so the x is equals to 0 position is this one, and the particle reached to this place after some time t is equals to t. So then its path will be like this. So then this is covered the angular displacement theta. Now you understood, right? So the second scenario equation I'll write here. Okay. So now, so the projection on the y axis. So the projection on the y axis will be here. So this will be the y now. So what is that y? So if it is theta, so this will be 90 minus theta. Yes or no? So this point will become cos of 90 minus theta. So the y is equals to minus a sin theta. I am writing y is equals to, because if it is theta, the simple logic, if it is theta, so this will be 90 minus theta. So if it is 90 minus theta, this vertical projection will be so cos of 90 minus theta. So or else you can simply write, if it is theta, this will be cos theta. Sorry, sin theta, y is equals to sin theta, as it is down, I can write minus a sin theta. So then you know that y is equals to minus a sin omega t. So this is the equation for S.H.M which is starting from the mean position towards the left extreme position. And similarly you can consider another scenario. Let's say the third scenario. I'll write the third scenario here. So where the particle is starting at time t is equals to 0. So the x is equals to 0 position. At time t is equals 0, x is equals 0. So now the particle is making the S.H.M. So in this particular path with a omega. So then, so let's say after some time t is equals t, it reached here. So then the particle reached here. So the projection of it on the y-axis we required. The projection of it on the y-axis. So if it is theta, so then this will be the y. So this y will be equals to a cos theta. Consider this as a. So this is a cos theta. Right. So as it is negative, so in the third scenario I am writing here. So as it is negative, so the y is equals to, so I can write minus a cos theta below the center, minus a cos theta, and the same calculations, the omega is equals to theta by t, so the theta is equals to omega t, right? So the y is equals to minus a cos, in place of theta you can write omega t. That's it. This is the equation of S.H.M, which is starting from the left extreme towards the mean position. Done. Clear? Sure. So let me do the fourth scenario here itself. So the fourth scenario I'll take from here. So at time t is equals 0, so the particle, let's say its initial displacement is 0. So now it's moving in this direction with angular velocity, let it be omega. So now after some time t is equals to t, so the particle has reached this place. Done. Chalo. So now, so the projection on y, so the projection on y, so this will be the one, so which I can write as, if it is theta, so obviously this will be 90 minus theta, or else you can simply take this as a sin theta, y is equals to a sin theta. Done. So the fourth scenario I am writing, so y is equals to a sin theta. So as it is above the center, I am taking it as positive itself. So y is equals to, I can write a sin omega t. So the particle which is performing the S.H.M from the mean position towards the right extreme position. So we got a cos omega t minus a sin omega t from right extreme to the mean position, from mean to the left extreme position. So from left extreme position to the mean position, from mean to the right extreme positions. So either you take it on the horizontal diameter, the overall understanding here it is what? So either the projections of uniform circular motion on the horizontal diameter, it performs S.H.M, and the projections of a particle which is undergoing S.H.M on the y-axis also performs a S.H.M. This point you should understand. Clear? So chalo. So now, so what if the particle starts from some initial phase? Every time, so we are taking time t is equals to 0, the position x is equals 0. But initially, already the particle has some phase. So initially the particle phi. So now here is the time t is equals 0. So it has started from this place. Now it reached to, let's say, some point here by making the displacement theta. Now, so what is the equation that we get? So the projection on any diameter you can take. If you want, you can take it in the horizontal or vertical. So let me take the simple one, the horizontal. So this will be x. So what is this total angle? This total angle is what? Theta plus phi. So then this will be 90 minus theta plus phi. 90 minus theta plus phi. So this side, so if it is the equation length a, so the x is equals to, so 90 minus theta plus phi is this side. So x cos 90 minus theta plus phi I get. Yes or no? So the simple thing. So therefore, so the x is equals to a cos of 90 minus theta plus phi. So which we can write it as, so x is equals to a into cos of, so what is cos of 90 minus theta? So which is nothing but sin theta. Yes or no? So then the sine of, so theta, what is theta here we have? So theta plus phi. Yes or no? Cos of 90 minus theta is theta, sin theta. Sin, this whole thing is a theta now. So which is nothing but, so the equation x is equals to a sin. So in place of theta, what you can write? Omega t, because the particle is moving with, so the angular velocity omega from here. So it's covering a displacement of, so theta. So then theta will be equals to omega will be equals to theta by t. So from there theta is equals to omega t. So which means, so the particles initial phase, when initial phase is given, so it starts from the mean position. Yes or no? It starts from the mean position with an initial phase. That means it's not exactly starting at the middle. At time t is equal 0, its displacement x is not equals to 0. It's starting from some displacement from the mean position. Clear? But it is going towards a right extreme position. We can say it from this equation. Done? Hope you guys understood now. So how the projections of the uniform circular motion, so will give the S.H.M, performs the S.H.M. Done? Chalo. So let's go for the next one. Obtain the corresponding S.H.Ms of x projection of the radius vector of the revolving particle P. So the particle revolving in a circular path, so that means it's undergoing uniform circular motion. So now we have to write what is its projection on the x. Okay, so at time t is equals 0, the particle is starting its uniform circular motion from here at time t is equals 0. So now let's say it's moving with some angular velocity omega. So after some time t, the particle has reached here. Done. So now the projection, this displacement they gave it as 3. So fine. So this is the angular displacement. Obviously the projection on the x, this will be x is equals to, as it is towards the left, minus a. So theta is here. So here sin theta will come. Done. So the x is equals to minus a sin theta. X equals to minus a sin theta. So in place of theta I can write omega t. Yes or no? So theta is equals to omega into t. So the x is equals to minus a sin, in place of theta we can write omega t. So the x is equals to, so what is a, amplitude is given 3. So minus 3 sin. So let's do one thing. The omega I am writing it as 2 pi by t into t. So here the time period, so the x is equals to minus 3. So the sin 2 pi by, so the time period is given as 2 seconds. Hope you are able to see that one. So here 2 into the time t, 2 cancel. So the x is equals to minus 3 sin pi t. So check for this option. X is equals to minus 3 sin phi t. Option 4 is the correct one, guys. Understood? Chal. So we don't need another slide for this. So let's take the next question. So what's the question says? The radius of the circle, the period of the revolution, initial position and sense of revolutions are indicated in the figure. So the particle at time t is equals 0. So it's starting the S.H.M from here. So then y projection of the radius vector of the rotating particle, y projection we required. So the time period is given as 4 seconds. So the a is given as, so first write the given information. So a is given as 3 meters. Fine. Chalo. So the particle has started its motion from here. So let's say, so the particle is moving with omega. So then at time t is equals to t, so the particle has covered the angular displacement theta. So with the angular velocity omega, so we know that omega is equals to theta by t, and then the theta will be equals to omega into t. The theta will be equals to omega into t. So from there I can write the equation. So the y projection we required. So the y projection, this one. So then theta is here. Obviously the y is equals to a cos theta. So the y is equals to a cos theta. Done. So then y is equals to a cos. So in place of theta what we can write? Omega t. So now substitute the values. What is a? 3 cos, let's write 2 pi by t into, so in the time let it be t itself. So 3 cos, so 2 pi by the time period is how much? 4, right? Yeah, 4 into t. So pi by 2. So 3 cos pi by 2 or pi t by 2 we can write. So 3 cos pi t by 2. So 3 cos pi t by 2. So option 2 is the correct one, guys. Understood everyone? Clear? Sure. So the next slide we do not require. So let's go for the energy in S.H.M. See, if the particle is undergoing the S.H.M, so it will have energy. So what kind of energies it will have? So consider the the pendulum simple harmonic motion without loss of energy. So when it is at the mean position, and then let's say it reached to some right extreme position, and then it reached to some left extreme position. So when right extreme and left extreme are at some height, right? So the right extreme and the left extremes are at some height. So that means at this point, so the particle which is performing S.H.M will have the potential energy. Here also, so the potential energy. So the potential energy maximum here, and the potential energy maximum here. Now, so this, consider this as a ground. So here the potential energy is 0, but potential energy is not always 0 at the mean position. Don't say that, because so that mean position can be some height from us, it will be some high from the ground. Let's say this is the ground, then the mean position is somewhat high. So the potential energy here will be minimum, not 0 exactly, because if it is on the ground, the mean position is on the ground, then potential energy we can consider 0. Okay, when the particle is coming from here to here, so it possesses so the maximum velocity, the V max, maximum velocity. So then at the mean position, so the particle contains the kinetic energy maximum. First understand the concept, then we'll go for the equations. So and at right extreme position, so the velocity will become 0, the particle's velocity will become 0. So here kinetic energy will become 0. And then here also the velocity, left extreme also the velocity becomes 0. So the kinetic energy becomes 0. Yes? Chal. So now let's go for the equations of kinetic energy and potential energy. You understood the concept, right? At extreme positions, the potential energy will be maximum and the kinetic energies will be 0. Okay. But at the mean position, the kinetic energy is maximum. Potential energy might be 0 if the mean position is exactly on the ground. If you consider the ground exactly from the mean position, so then potential energy is 0. Otherwise, so if the ground is somewhat high from the, or some low from the mean position, so the potential energy is minimum at the mean position. So the write down this point, it need not to be 0 always. The potential energy is 0 at the mean position. Clear? Understood, guys? Now let's go for the kinetic energy equation. So we know that the kinetic energy of the particle which is performing S.H.M, let's say it's moving with the velocity v. So the half the particle's mass, let it be m. This is a bob of mass m, it's moving with the velocity v. So then I can write half mv square. Done this part? Yes. So then we already know that what is the equation for the velocity of the particle. In the second class we discussed. So the basic terms related to S.H.M. So there the velocity of the particle which is performing the S.H.M, v square, is equals to omega square into a square minus x square. Did you guys remember this formula? Yes. So now this velocity formula I am substituting it here. So the kinetic energy Ke is equals to half m into what is v square. So I am writing omega square into a square minus x square. Just in place of this v square I am writing omega square into a square minus x square. So then did you see this term anywhere? What is m omega square? In the S.H.M, so the k will be equals to m omega square, right? So F is equals to minus kx, the restoring force. F is equals to minus kx, where F is a restoring force you learned. Right, it's a restoring force. So in this, so the k is what? So the k is m omega square. The k is m omega square. So the same thing I am substituting here. So the ke is equals to, so half here k in place of m omega square, so into a square minus x square. So this is the equation of kinetic energy. This is the equation of kinetic energy. Now So this kinetic energy, where it will be maximum and where it will be minimum. What's the kinetic energy that we got? So the Ke is equals to half K into A square minus X square. Understand the concepts carefully. A square minus X square. Done guys? Chalo. So here I can take, so the when X is equals to 0 at the mean position, the X will be equals to 0. If the X equals to 0, so the kinetic energy will be maximum. So the kinetic energy maximum at the mean position. That's what we discussed, right? So what is that mean maximum value? Half into K into, so the X is 0. So simply I can write A square. So that means kinetic energy maximum formula is this one, or you can also write as, so the Ke max is equals to half, in place of K you can write m omega square A square. This is a maximum kinetic energy, where at the mean position. So now let's consider at the extreme position. Let's consider at the extreme position. So in extreme positions, the X will be equals to plus or minus A. So however square we are doing, so let's write plus A, or you can keep plus or minus, your wish. The X is equals to plus or minus A. Chalo. So next I have, so the kinetic energy will be equals to, so what is that kinetic energy? Now it will be minimum. So this term will become 0. In place of X, if you substitute A square minus A square, 0. So 0 into something, 0. So that kinetic energy will be minimum, which is 0 at the extreme positions. Understood guys this part? Clear everyone? Chalo. So next. So then I'll go for this equation. See here. Fine. Done this part? Chalo. So noted this one. Chalo. So now let me go for the graph. So the kinetic energy, basically we got half mv square for a particle which is moving with the velocity v. So the kinetic energy is half mv square. Now let me consider the basic equation of the S.H.M. So let's say the particle is performing S.H.M from the mean position. Let's say the particle is performing S.H.M from the mean position towards the right extreme. That's the most popular equation of S.H.M, right? So where the X is equals to, I can take A sin omega t if it is performing in the X direction, straight line. So the to and fro, not back and forth. So then, so the X is equals to this one. So then I can write what is the velocity. So the dx by dt. So which is nothing but d by dt of A sin omega t. So then I'll take, so v is equals to A common. So the sin A omega cos omega t. You already know this. I am not going in detail this one. So then what will be the kinetic energy? So the kinetic energy will be equals to half m into, in place of v I am substituting this one, A square omega square into cos square omega t. Just I am doing the square. A half m into v square, in place of v square, A omega cos omega t whole square. So then let's write the kinetic energy is equals to half m A square omega square into cos omega t, cos square omega t. So this whole thing, so this is a K naught. So let's say this is a K naught. So the maximum kinetic energy. So the Ke is equals to, so K naught into cos square omega t. So my intention is to draw the kinetic energy versus time curve. That's it. Okay. So that's why I'm taking this equation. So here, if you take the kinetic energy versus time, the kinetic energy versus time. So the cos curve, it starts from where? The right extreme. So this is how the graphs look like. Okay. So if you want, you can substitute the values. So this comes at the t by 4. So then this will be at the t by 2. So then 3t by 4 and then t. If you want, you can substitute. So let's say if you take the t is equals to t by 4. So if t is equals to t by 4, so then cos square omega, what is omega? 2 pi by t. So into, so the t by 4. So t gets cancelled. So 2 ones are 2 2s are. So cos square pi by 2 0. Yeah, 0 you are getting, right? At t by 4 it is 0. Cos square pi by 2 is cos pi by 2 is 0, right? Cos 90. So that you are getting 0 here. Again at t by 2 if you can substitute, you will get the maximum. Done. Clear everyone? Chalo. This is a Ke versus T curve. And next let's go for the potential energy. So the potential energy, you can just compare it with the spring potential energy. Here the potential energy of the particle which is performing S.H.M, so which is half kx square. It's a potential energy stored in a spring. Did you remember? We discussed the questions related to this as well in the work energy power. So the compressed spring or the stretched spring will possess a potential energy of half kx square. So here this is a potential energy. Now where it will be maximum and where it will be minimum. So let's write that also. So consider, let's say, at the mean position or the at so at mean position the x equals to 0 we take, right? So then the u will be 0. So when the mean position is exactly on the ground, but if it is not exactly on the ground, so then the potential energy minimum, it can be sometimes u naught as well. Okay, chalo. So and then the extreme position, consider the extreme position. So there the x will be equals to plus or minus a. So plus a if you substitute or minus a if you substitute. So however we are doing the square. So then the u will become half k a square. Half k a square. This is a maximum potential energy. So this is a maximum potential energy which is half k a square. Or I can also write the maximum potential energy as half k a square, or we can write in place of k you can write m omega square into a square. M omega square into a square. This is a maximum potential energy. Understood everyone? Clear? Chal. Good. Next. So let me draw the potential energy versus time curve now. So let's say the particle is performing the S.H.M from the mean position, where, so the x is equals to a sin omega t. X is equals to a sin omega t. Fine. So the potential energy is equals to, we know that, half kx square. Now so u is equals to half k into, in place of x let's substitute a sin omega t whole square. Done. Chalo. So then half is equals to half into k a square into sin square omega t. So half k a square is nothing but, so the maximum potential energy, half k omega square is nothing but maximum. So here u is equals to u max into, this whole thing is a u max into the sin square omega t. Done. So now the sine graph, so square means the negative cycles will be cancelled. Actually the sinusoidal graph should be like this. Yes or no? So but as it is square, only the positive cycles will be there. Yes or no? So the negative cycles will be cancelled. So then if you draw the potential energy versus time curve, so the time versus the potential energy, so then it will be, right? So at 0, so t by 4, so t by 2, 3t by 4, so t like that. Understood guys? The kinetic energy versus time and the potential energy versus time, and what is the kinetic energy maximum, potential energy maximum, kinetic energy minimum and potential energy minimum. Hope you guys understood these calculations. Done? Sure. So let's go for the graphs of Ke and Pe versus x. Already we discussed this, right? Or else let's write both in a single graph. So how the Let's do this way. So shall I write like the potential energy versus, I am not taking exactly 0. So this is the potential energy, x is equals to minus a position, x is equals to plus a position, and this is a mean position, x equals to 0. So the potential energy is minimum at the mean position and it is maximum at the extreme positions. So left extreme and the right extreme position. And then one more thing, so the potential, the kinetic energy, if you draw, so the kinetic energy will be minimum at the mean position, sorry, maximum at the mean position. This is a Ke max and this is U max, and this is also, so the potential energy maximum, and this point is a potential energy minimum. Hope you guys understood now. Clear the graphs? So whenever the potential energy is minimum, the kinetic energy will be maximum. When the kinetic energy is minimum, that is 0, so the potential energy will be maximum. So when the kinetic energy is 0, so the potential energy will be maximum. Done? Understanding this part? So both the graphs I drew in one. Clear? Sure. So then what is the total mechanical energy in S.H.M? So the total mechanical energy in S.H.M is equals to, so the summation of kinetic energy total plus the potential energy total. Okay, write the basic equation. So half mv square, half m, in place of v I am writing v square, in place of v square shall we write omega square into a square minus x square. Can we write like this? So then, so here the potential energy half kx square, or else let's write okay, so half kx square. So this equation also I am writing it as half, so in place of m omega square let's write k, better. So k into a square minus x square, so plus half kx square. Done? Chal. So here half k a square minus half k x square, so plus half k x square, just I multiplied it inside. So here half k x square cancel, so that is half k a square. So what is this half k a square? So the total energy. So that means the total energy, if you observe, the total energy is equals to, so the kinetic energy max formula, the kinetic energy will be maximum at the mean position, right? So at x is equal to 0, the kinetic energy max will be half k a square, or you can see from here. So the maximum kinetic energy is half k a square, this one half k a square. The total energy also we got, what's the total energy? Half k a square. So and that is also equals to the potential energy maximum, just now we have seen. So what's the maximum potential energy? The maximum potential energy is half k a square. So that means the total energy is equals to kinetic energy max and potential energy max, which is equals to half k a square, or which is equals to half k is nothing but m omega square a square. So which means the energy is becoming constant, the total energy is becoming constant. So this is called the conservation of energy, right? So you can understand it through graph as well. So when the potential energy is maximum, the kinetic energy is minimum. When the kinetic energy is maximum, the potential energy is minimum. When the potential energy is maximum, the kinetic energy is minimum. And when the, here the kinetic energy plus potential energy will be equals to the total energy. Here at some other point, the kinetic energy plus potential energy will be equals to total energy. Here the U max is equals to the total energy. Here the U max is equals to the total energy. Here the kinetic energy max, which will be equals to the total energy. That means energy is getting conserved at any point of the S.H.M. Understood? So the conclusions are important. The questions can be framed directly. You guys should remember all these important points. You don't know in the NEET how the questions will be framed. sometimes the questions will be directly picked from the statements itself. Understood everyone? Chalo. So this is the total energy. So kinetic energy, potential energy, and the projection of uniform circular motion on diameter. Clear? Understood, guys? So the questions related to the energy part, like kinetic energy, potential energy, total energy, we'll do it in the next session. Okay, so till then, keep studying. We'll meet in the next lecture with a new topic, guys. So till then, keep studying. All the very best. Bye.